Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0453, indicates a high voltage condition in the fuel tank pressure FTP sensor circuit of the Honda CRV models from 2017 to 2022. The FTP sensor plays a crucial role in monitoring the pressure inside the fuel tank, which helps achieve optimal emissions control by ensuring that fuel vapors are managed properly. This sensor is typically located near the fuel tank, making it an integral part of the Evaporative Emission Control System, or EVAP. The EVAP system is designed to prevent fuel vapors from escaping into the atmosphere, which is essential for compliance with environmental regulations. When the FTP sensor circuit sees a voltage higher than the expected threshold, the engine's powertrain control module, or PCM, records the P0453 DTC, alerting technicians to investigate further. If this DTC is confirmed, the vehicle may exhibit symptoms such as poor fuel economy, rough idling, and an illuminated check engine light. The DTC P0453 refers specifically to the FTP sensor circuit, indicating a high voltage scenario that could affect the vehicle's operation. The FTP sensor's primary responsibility is to gauge the pressure inside the fuel tank. By monitoring this pressure, the FTP sensor helps the EVAP system in managing fuel vapors from being released into the atmosphere. This sensor is installed at the fuel tank's top, ensuring it can effectively monitor the conditions within the tank. The ECU, or PCM, which is the central processor of the vehicle's engine management system, uses the information from the FTP sensor to optimize fuel atomization and engage the Evaporative Emission Control System appropriately. When the FTP sensor circuit reports a voltage level greater than the specified threshold of 4.7 volts, the PCM categorizes it as a malfunction, resulting in the triggering of DTC P0453. It is essential to address this code swiftly to maintain vehicle performance and reduce emissions. Several possible causes can trigger the DTC P0453 code. One of the primary suspects is a faulty FTP sensor itself. If the sensor is malfunctioning or internally damaged, it may erroneously signal high voltage to the PCM. Another potential culprit could be wiring issues, particularly any broken or shorted wires leading to the PCM. Such electrical anomalies can lead to incorrect voltage readings and consequent error codes. Additionally, loose or poorly connected terminals at either the FTP sensor or the PCM can interrupt the proper flow of data and power, causing diagnostic trouble codes to be flagged. It is essential to systematically check each of these components to ensure that the problem is accurately identified and resolved. When DTC P0453 is present, several symptoms may manifest that can affect the overall performance of your Honda CRV. The most immediate indication is the illumination of the check engine light on the dashboard. This warning signifies that the engine management system has detected a fault that needs to be addressed. Additionally, drivers may notice reduced fuel efficiency due to the engine not performing at its optimum level. An improperly functioning FTP sensor can lead to poor air-fuel mixture readings, further exacerbating fuel consumption. Lastly, rough idling may also occur, potentially making the driving experience feel less smooth and indicating an underlying issue within the fuel management system. It's crucial to pay attention to these signs, as they can indicate a need for prompt action to prevent further complications. The first step in troubleshooting DTC P0453 involves ensuring that all preliminary checks are completed. Begin by turning the vehicle to the on mode to power up the electrical systems without starting the engine. Use the Honda Diagnostic System, HDS, to clear the existing DTC codes. This action allows you to reset the onboard system and can sometimes eliminate false errors. After clearing the code, turn the vehicle back to the off mode and insert the emergency fuel funnel into the fuel filler neck, which is stored under the cargo lid. Next, with the HDS still connected, monitor the parameters related to the FTP sensor. Check for the voltage reading. It should be less than or around the threshold of 4.7 volts. If the current conditions match the malfunction threshold, proceed to the next troubleshooting step. In the second troubleshooting step, removing the emergency fuel funnel is essential to return the vehicle to its normal operating state. Start the engine and maintain the RPM at 3,000 with no load, which means the vehicle should be in either park or neutral. This action allows the vehicle's engine management system to perform self-tests under conditions that simulate normal operation. Continue to monitor the OBD status using the HDS for any recurrence of DTC P0453. If the HDS indicates that the DTC is still flagged as failed, it confirms that there is a persistent issue with the FTP sensor or related components. If the status shows passed, it may indicate an intermittent fault, leading to checking for poor connections or loose terminals at the FTP sensor and the PCM. This step allows for a more focused diagnosis of the fault present. The third troubleshooting step requires you to turn the vehicle back to off mode before proceeding. Disconnect the 3P connector from the FTP sensor to isolate it from the circuit for testing. Following this, you'll need to create a temporary connection between terminal A and terminal B in the FTP sensor connector using a jumper wire. Terminal A corresponds to female terminal number 1, and terminal B corresponds to female terminal number 2. After making this connection, turn the vehicle back to the on mode. With the HDS, check the voltage output from the FTP sensor. It should read above the threshold of 4.7 volts if the sensor and the circuit are functioning properly. If the readings confirm the condition of exceeding the threshold, proceed to the next step in the troubleshooting process. In step 4, you will remove the jumper wire you connected previously to isolate the FTP sensor for independent checks. Ensure the vehicle is still in off mode, and then reapply power by turning it to on again. At this point, you'll measure the voltage between the designated test points within the FTP sensor connector. Test point 1 corresponds to female terminal number 1, and test point 2 corresponds to female terminal number 3. A voltage reading around 5.0 volts indicates that the circuit to the FTP sensor is intact. This verification process helps in isolating whether the issue is with the sensor or potentially elsewhere in the wiring harness. If no voltage is measured, you will move to the next troubleshooting stage, which involves examining the wires for any cuts or breaks. The fifth troubleshooting step is focused on verifying the wire integrity for the P-tank line. Begin by ensuring the vehicle is in off mode. Using the HDS, jump the SCS line and allow the system to sit idle for over a minute to ensure that it can read the test results accurately. Next, disconnect PCM connector A, which typically houses a series of 51 pins, to facilitate testing. Following this, connect terminal A from the FTP sensor to terminal B, which should be a designated body ground point, establishing a path for measuring continuity. After making this connection, check for continuity between test points. Test point 1 should connect at the PCM connector A utilizing number 42, and test point 2 should be a grounded point. Confirming continuity here signifies the P-tank wire's status. If continuity exists, the wire is okay, and further checks should proceed. If not, you will need to investigate any open in the P-tank circuit. In the final troubleshooting step, The focus shifts to the SG6 wire associated with the FTP sensor to ensure its integrity and functionality. Similar to the previous steps, start with the vehicle in off mode while using the Honda Diagnostic System to jump the SCS line for testing purposes. Disconnect the PCM connector A to allow you to access the necessary terminals. Utilize jumper wires to connect terminal A from the FTP sensor to a solid body ground. With this connection in place, measure continuity across the test points. Point 1 should connect through the PCM at terminal A28, while test point 2 should again be a reliable ground. Achieving continuity indicates that the SG6 wire is functioning correctly. If no continuity is found, that would indicate an open circuit within the SG6 wire, indicating that repairs are necessary to restore functionality and ensure the proper operation of the FTP sensor. After completing the required repairs for DTC P0453, it's crucial to perform a final verification to ensure everything is functioning correctly. Start by clearing the DTC through the Honda Diagnostic System, HDS, to reset the vehicle's monitoring systems. Once the DTC has been cleared, conduct a test drive to allow the vehicle's control module to re-establish its operating conditions and recalculate various parameters. During this test, pay close attention to vehicle performance and monitor the system for any recurring issues. After the test drive, re-evaluate the DTC status using the HDS. This will ensure that no new error codes have emerged and that the FTP sensor circuit is now functioning within acceptable parameters. Achieving a successful reset and no new trouble codes is essential for confirming the repair's effectiveness. Preventive maintenance plays a crucial role in avoiding issues like DTC P0453 in the future. Regularly checking connectors related to the fuel tank pressure sensor can help identify any signs of wear or damage before they create larger problems. Tight and clean connections are paramount to ensuring that signals between the FTP sensor and the PCM remain uninterrupted. Additionally, it's advisable to inspect the FTP sensor periodically for any signs of degradation or leaks, as these can lead not only to DTC codes, but also increase emissions levels. Maintaining proper fuel levels within the tank is equally important. Both overly low or high fuel levels can cause issues within the FTP sensor readings. By staying proactive in these maintenance tasks, you can help ensure that your Honda CRV remains in peak operating condition and potentially avoid expensive repairs down the line. In conclusion, DTC P0453 reflects a critical condition regarding the use of the fuel tank pressure sensor within the Honda CRV models, ranging from 2017 to 2022. It is essential to address this code promptly, considering it can lead to performance issues, increased emissions, and possible long-term damage to the vehicle's systems. Thorough troubleshooting steps enable technicians to pinpoint whether the fault lies with the sensor itself, the wiring, or the PCM. Ongoing vigilance with routine checks of connectors, sensors, and wiring, as well as following up with recommended preventive maintenance, can greatly enhance vehicle reliability. Maintaining awareness of these elements will ensure your Honda CRV operates efficiently and minimizes the chances of similar issues in the future. Ultimately, attention to detail in troubleshooting and maintenance will lead to a well-performing vehicle. Please like and subscribe to the channel. See you next time!